Okay, let's talk about element number 1. It's the lightest, the simplest, and by far the most abundant thing in the entire known universe. We are, of course, talking about hydrogen. And today, we're going to dig into this fundamental building block, from how it forges stars to its potential to power our future. All right, let's get into it.
So, what's with this number, 75%? Well, that's hydrogen's share of all the normal, visible matter in the cosmos. Think about that. 3/4 of everything we can see out there, from the biggest star to the smallest wisp of a nebula, it's all made of this one simple element.
And its influence? Oh, it's literally everywhere. It's the fuel for the nuclear fusion that powers our sun and pretty much every other star in the sky. Back here on Earth, it's a key piece of the water that covers our planet and the organic molecules that make up life itself. And, on a historical note, its simple structure was the key that let scientists unlock the completely bizarre and wonderful world of quantum mechanics.
Which, of course, brings us to the big question. We know what hydrogen has done for the universe and for science, but can it play a whole new role in our energy-hungry world? Let's find out.
So let's start with the absolute basics. What is hydrogen really, and what different forms can it actually take? At its heart, hydrogen is just beautiful in its simplicity. Its atomic number is 1, and that's because its nucleus has just a single proton. Orbiting that proton is a single electron. That's it. That's the whole shebang, which makes it the lightest of all the elements on the periodic table. But, it's not just one thing. It's better to think of hydrogen as a small family of isotopes. Now, they all had that one essential proton. That's what makes them hydrogen. But they differ in how many neutrons they're carrying. So let's meet the family.
First up, you've got protium, the superstar, no neutrons at all. This one makes up more than 99.98% of all hydrogen out there. Then there's deuterium, the stable sibling. It's got 1 proton and 1 neutron. It's pretty rare, but it's really important, especially in things like nuclear reactors. And finally, you have tritium, the radioactive cousin, packing 2 neutrons. It's incredibly rare and it decays over time, but it's crucial for some very specific applications, from fusion research to glow-in-the-dark lighting.
But hydrogen's simplicity also happens to be at the center of one of science's greatest detective stories. By studying the light coming from its atoms, we completely rewrote our understanding of reality itself.
Now, the key to this whole mystery is something called a spectral series. See, every element, when you give it some energy, gives off light. But it doesn't just glow in all the colors of the rainbow. Instead, it emits light at very, very specific wavelengths, creating a unique pattern, kind of like a fingerprint. And that pattern comes from its electrons making these tiny little leaps. So here's how it works. First, an electron in a hydrogen atom gets all excited and jumps up to a high-energy shell. But it can't hang out there forever. So it jumps back down to a lower, more stable energy level. And in that single leap, it has to get rid of that extra energy, which it does by releasing a photon, a single particle of light with a very specific color. And this is what you get. For hydrogen, these jumps produce this unmistakable pattern of 4 visible lines of light. We call it the Balmer series. You can seriously think of it as hydrogen's cosmic barcode. When astronomers point their telescopes at a distant star and see this exact pattern of red, aqua, blue, and violet, they know with absolute certainty that hydrogen is there.
So the really crucial point here is that figuring out why hydrogen produced this specific barcode was a massive breakthrough. It actually forced physicists to develop the theory of quantum mechanics. It showed them that energy levels inside an atom aren't like a ramp, but more like a staircase. They only exist in specific, quantized steps. Hydrogen's simple structure was the perfect key to unlock that incredible secret.
Okay, so we've gone from the quantum world, let's get practical. How do we actually make the hydrogen we use for industry and energy down here on Earth? Well, it turns out the color makes all the difference. And this chart, wow, it tells a pretty stark story. Right now, something like 95% of the world's hydrogen is produced directly from fossil fuels. That means the vast majority of our hydrogen supply is tied to the very energy sources many people hope it's going to replace. Only a tiny, tiny fraction is made using cleaner methods.
So this slide breaks down the 2 main paths. On the left, you've got gray hydrogen. This is the main process, called steam reforming. You take methane, which is just natural gas, and you react it with super hot steam. It works, you get hydrogen, but you also get a massive byproduct, carbon dioxide. On the right, you have green hydrogen, made by electrolysis. Here, you use electricity to split water molecules into hydrogen and pure oxygen. No carbon emissions in the process itself.
And this right here shows you the huge problem with gray hydrogen. The environmental cost is staggering. For every single ton of hydrogen you produce this way, we're pumping somewhere between 6 and 9 tons of CO2 into the atmosphere. It's a clean fuel with a very, very dirty backstory.
Which brings us to our final and, let's be honest, our most urgent question. Given all these challenges, can hydrogen really be the thing that fuels our future? Let's start with the potential. This number represents the energy density of hydrogen by its mass. At 141.8 megajoules per kilogram, it packs way more energy per pound than any conventional fuel we use. It is, just by its nature, an incredibly powerful way to store and carry energy.
And that energy can be used in so many different ways. It's already essential for things like making fertilizer for our farms, but its future uses are even more exciting. Things like providing the intense heat needed for making steel and cement, generating clean electricity in fuel cells, and even powering rockets into space.
So what's the verdict on this idea of a hydrogen economy? Is it all hype, or is there real hope? Well, the hope is pretty clear. It's a versatile fuel, and when you use it, the only thing that comes out is water. It could be perfect for cleaning up tough sectors like shipping and aviation. But the hype crashes into some hard realities. Hydrogen is incredibly difficult and expensive to store safely. It's highly explosive, and it can even damage the metal containers used to hold it through a process called hydrogen embrittlement. So we end up right back where we began, with a really fundamental question. This simple element, born in the first few moments after the Big Bang, managed to build the stars and light up the entire universe. The question for us is, can we overcome its very real challenges to harness its power and help rebuild our world on a cleaner foundation? That right there remains one of the greatest technological challenges of our time.